So I have spent a lot of time talking to the media because the media is a major conduit to the public. I also have a science background, having a science degree, and found myself actually drawn to communications at a time period where people were looking for people with a science background who could help them communicate with the public, and started with the Alzheimer's Association when they were a very young organization as opposed to the large organization they are today. So the media is essentially a conduit to the people that we really want to reach. And we know that the media is very powerful and can reach millions of people very quickly, and they're a major source of information about scientific developments. A lot of the stories that are covered in the media shape public policy. You hear about that much more as it relates to investigations of particular agencies, particular issues, but it also happens, people use the media to shape public opinion, particularly about the whole debate about stem cells and whether or not the government should fund stem cell research is something that played out in the media over time. Essentially, scientists and journalists have a responsibility to collaborate, to deliver science news to the public, but also to make sure that that news is accurate and that it tells the right story. And we're going to talk a little bit about that today. To give you an entire course on the media would take a lot of time, so I'm going to give you a lot of high-level information. When we get to the Q&A, you might want to drill down on it. But the media is not one animal. It's many different forms, from print media that we're all familiar with because we all carry a lot of print media with us on a regular basis, newspapers and magazines, as well as broadcast media, and then the internet being the newest form of media where all of those things are happening, both content that can be printed as well as content that comes in audio as well as in video. And the reason it's important for scientists to really think about the role that they play with the media is because the world is changing, and the world has changed tremendously. Even the media has changed with the introduction of technology, and technology has changed the speed at which we communicate as well. So this is a quote from Dr. Alan Leshner that was taken from a study I'm going to show you later that looks at scientists' perception of how well are the media doing in communicating, as well as the public's perception in terms of how are they consuming what the media is reporting. But essentially there are three elements here I want you to pay attention to, and that is the contribution to a respectful dialogue. In the sciences you learn a lot of technical terms, a lot of technical information, and oftentimes it's hard to figure out exactly how to talk to people who don't have a science background about science, but it's really important for you to think about that, particularly as your research evolves, and particularly if your research is going to be shared with the public. Also, making sure that you leverage popular culture. So we've talked about how the media have changed. Well, the internet has changed the game entirely. Anyone can be a journalist. It's actually the age of what they're calling citizen journalism, where anyone can create a blog, anyone can go online and create a website. So there's a lot of freedom to do that, but there's also a proliferation of a lot of information. Not all of it is good. But scientists don't have to wait essentially to have their voice in those medium, because you can create forms for your own voice. You don't have to use the media singularly as we had in the past. Newspapers, the newspaper business has changed a lot. You talk to any newspaper journalists and you know that there are fewer and fewer newspapers. Right here in Philadelphia, we know that our own newspaper filed for bankruptcy and had to reorganize and may or may not live, because people aren't reading print anymore. I happen to belong to the baby boomer generation. I'm at the tail end of the baby boom generation, but I love print. I grew up with it. I grew up reading the newspaper, reading magazines as a major source of information. I have a daughter who is in the millennial generation, and she looks at news entirely differently. She gets all of her news online from sources that she trusts. I am probably a hybrid at this point, but I'm still very much tied to print media and still love to pick up a magazine. Even with e-readers, I pull content in from all those sources, but I still find myself really liking these print publications. So a lot of newspapers are folding. 24 of the top 25 newspapers saw a decrease in circulation. People are trying to figure out their business model and whether or not they can tweak that in order to survive. In the meantime, staffs are shrinking. People who had particular beats are actually, if you were a science reporter, you might be covering science, medicine, and business for pharmaceutical companies. So you may have this whole universe that you have to cover on a daily basis. Science sections in newspapers are declining. The number of science sections have declined, as well as the amount of content. That's what a news hole is. It's the amount of content that's actually in the news. So there's a lot of brief reporting as opposed to a lot of in-depth coverage. And then there's the hybrid model, because all of the print publications have online spaces. I saw in discussion over the last week, when a lot of those newspapers and television stations started, all the content was free of charge. They're now finding that they need to rescind that model simply because with newspaper readership declining, online news becomes a source of revenue. So I heard that the New York Times is now going to charge about $20 a month for you to access the New York Times online. So that's one way in which they survive. Circulation's down 7 million over the last 25 years. That's very significant. Staff science reporters are dwindling, and we see this shift towards consumer coverage of health. So this is the Time magazines used to have separate sections for health, separate sections for science. This is their new section. One page dedicated to science, health, and medicine. So this is what we mean by news holes. All short, all very, very brief, not very detailed at all. Television, I'm sure all of you probably, without me telling you, know that there are thousands of television stations. With the advent of cable, the number of television stations has grown significantly, as well as with CNN being launched in 1980, we saw the evolution of 24/7 news. Prior to CNN, prior to 1980, you never saw television stations running continuously. Martha and I talked about how when we were kids, television went off at night, something that may be foreign to all of you, but it actually went off at 11 o'clock at night. There was no more television. And it's hard for people to believe that, but that's certainly the way it used to be. Now you can turn on the television anytime, day or night, and get programming that causes the media to have to fill a lot of space, and that relates to a lot of what they cover and how they cover it, because they have a lot of time and they have to push things in it. So sometimes we talk about, well, that, some of the things you see don't seem like they're very newsy, but when you have to fill a 24/7 hole, a lot of things make it that wouldn't otherwise make it. When I was a kid, the news really was news, and now everything is pretty much news. But the average length of those segments are very short as well. When you look at television news, you can miss an entire segment on television if you get up at the wrong time and go to the bathroom. Nowadays, people can also have these recorders where they can actually record things and take the commercials out, and so they can look at television footage later. But if you're not looking at it live, you can miss a lot of what happens on television. And televisions have websites as well. So what they're doing a lot of the times is they're expanding a story online because they have such a short window in the actual live coverage where they will send you to the website and you can get a lot more content and they can dive deeper into the story. So that's a positive. I'm going to show you a couple of television videos that really get to the issue of how the television stations are covering news. One of them will be what we call a brief, and that would be something like what you see in Time magazine, only it would be on television instead. And this is a news anchor who's going to report a story.
New medical findings that could complicate some end-of-life decisions for doctors and families. A brand new study looked at patients in a vegetative state and found many are more conscious than previously believed. They showed brain activity when questioned about familiar names or given instructions. The New England Journal of Medicine says it will now be difficult for physicians to tell families confidently that their unresponsive loved ones are not in there somewhere. It is a record-shattering day in the art world.
So that's a brief. The anchor person there, Diane Sawyer,
now imagine unplugging your BlackBerry,
without
your iPod, your laptop, everything and anything digital in your life.
Without interviewing anyone, actually took the copy of the New England Journal of Medicine piece. Every week, the New England Journal would send out a media kit to the media, so a week ahead. So if the publication publishes on Thursday evening, a week ahead, the media would get a press kit that would outline those things that they had determined they wanted them to pay attention to in that issue. So it's clear that that was one of those stories that they wanted them to pay attention to. Oftentimes, the folks at the American Medical Association will publish video footage as well as send a press kit. And what that does is the images that you saw, it gives all that information to them. So as while they're telling the story, they have this source to draw on of material that's been essentially blessed by the publisher and hopefully by the author of the paper as well. Hopefully the author has participated because when these press kits go out, the first thing that's going to happen is the media is going to want to get their story ready and talk to the author of the paper before the paper actually publishes. They send those out on what they call an embargo to give them time to do that. So you'll see that's how you can see a story run on the very same day that the journal actually publishes. The other piece is a longer piece. So this footage actually was provided by Vanderbilt University, who has an archive of television news that they keep. So you can borrow this footage from them, but you can't embed it.
In tonight's CBS News in Focus, we focus on the most amazing machine in the world, the human brain. Emily Dickinson wrote, "It's wider than the sky and deeper than the sea." Actually, an adult brain weighs only about 3 pounds. 80% of it is water. The brain is packed with 100 billion neurons, sending messages at 220 miles an hour. And it's as much as 100 million times more energy efficient than a modern computer. The brain has long been the most mysterious organ in the body, but science is now shedding new light on how it ages, handles stress, even repairs itself. So tonight we explore the newest frontiers in brain research as we begin a CBS News Time Magazine series we're calling A User's Guide to the Brain. Our new contributing correspondent and practicing brain surgeon, Dr. Sanjay Gupta of CNN, is here. Sanjay, we're learning so much about the brain these days.
Yeah, it is remarkable. One of the long-standing beliefs was we believed that the brain had nowhere to go but down. But new research is showing that through mental exercise, you can actually keep your memory as you age. You can even create new brain cells.
So we're walking right now. What's happening to my brain?
Well, what we found in our study is that walking will increase the volume of the brain, increase the efficiency of the brain, and increase a number of improvements in a number of cognitive processes, such as memory and attention.
Just by walking?
Just by walking.
Professor Arthur Kramer of the University of Illinois in Urbana is part of a revolution, challenging a long-held belief in the world of neuroscience that the brain is hardwired, fixed, immutable. He says changing the size and the function of your brain is as easy as taking a few steps.
We walk at 40 minutes.
78-year-old Grace Miller walked 3 days a week for 6 months.
Have you noticed the difference?
I really think so. My husband and I, we kind of try to remember things. Lately, I've been doing all the answering.
We do know that over about a 6-month period, you can get about a 15% improvement in memory and attention and a variety of
In
other
6 months?
In 6 months, right.
That's pretty remarkable. Professor Kramer took pictures of the brains of 60 participants before and after 6 months of walking and saw an increase in crucial areas responsible for memory and decision-making.
I was surprised at how much plasticity, how much flexibility older brains have, because the general belief up until about a decade or so ago was that that brains deteriorated as we age. That's not true.
Not true at all. Plasticity. It's the actual strengthening of connections between neurons, stopping, yes, even reversing memory loss. Physical exercise helps, and so do mental exercises.
The brain is actually revising itself. It's actually plastically changing itself as you develop new skills and abilities, as you learn new things.
Professor Mike Merzenek of the University of California, San Francisco has in many ways turned neuroscience on its head by championing this idea of plasticity. He has even developed a computer program called Brain Fitness, which is commercially available for almost $400. Users make thousands of decisions per hour. The result? possibly a mind that is 10 years younger. Seniors at the Heritage Estates in California say it's made a difference.
It stimulates your brain and it really makes you remember and want to remember.
To be clear, what Merzenich is selling hasn't been independently proven to work. But a recent study in the Journal of the American Medical Association says that the benefits of cognitive training like this can last 5 years.
You know, without question, there's also already lots of good reasons to exercise. We already know that. But this idea that you can actually train the most important muscle of all, your brain, that's coming to reality. People are starting to believe this.
I tell you, I'm going to hit the treadmill when I get home, Sanjay. Meanwhile, what about people who are already suffering from dementia or Alzheimer's? Can mental and physical exercise restore their memory?
Well, here's what we know. Once you get to the stage of Alzheimer's, probably not. At least there's no studies to indicate that you could. But in people who are starting to develop Alzheimer's, who have early cognitive problems, the answer is yes. And the most exciting thing, I think, Katie, is that you can actually measure that. These scans show those areas of the brain responsible for memory actually growing in response to physical and mental exercise. So yes, there's hope for people who may have early Alzheimer's or early dementia.
It really is exciting. Sanjay Gupta, again, welcome. So happy to have you
Thanks
here.
for having me.
Our CBS News Time Magazine series, A User's Guide to the Brain, continues tomorrow here on the CBS Evening News with some amazing new science that may allow the blind to actually see with their tongues. And tomorrow morning on the early show, how a brain-injured woman spoke for the first time in 20 years.
So this is an evening news piece, a very long-form piece, but again associated with a collaboration with Time Magazine. So I don't know if you are aware of how the media has consolidated over the last decade or so, but many television stations own newspapers as well as magazines. So most of the major television stations have some tie to newspapers and magazines because of that. Try and get my presentation back here. Then we talked a little bit about the internet and how much it has grown. It was 1994, I believe, when the public got access to the internet, and you started to see the proliferation of websites. Now we see that there are the readership online has increased 34 million in the last 5 years. That more than half of Americans get their news online. And again, we talked about the fact that a lot of newspapers are online, so it's really not hard to do. It's actually very easy to get your news online, and now with iPad, you can get your newspapers and magazines downloaded onto your iPad, so you can take them with you. There's a proliferation of video. I'm sure all of you know about YouTube. Well, YouTube isn't just populated with funny and entertaining videos anymore. A lot of scientists have put video on the site as well. So there's a lot of content out there. And there's more than 1 trillion web pages already, as well as 1.8 million blogs. So there's a lot of information that one has to go through to determine what's actually worthwhile. There are a number of science blogs. Some of them are associated with science publications, such as Scientific American. There's a Wired Science site that has various channels. There's the Frontal Cortex that's very focused on neuroscience. Some of these are written by journalists, but some are also written by graduate students. The Frontal Cortex is written by a graduate student. So again, you don't have to have any particular training or background to write a blog. There's a lot of podcast material as well, simply because people like to be able to get information in various formats. So Scientific American, as well as Nova and National Public Radio, have some wonderful science-related podcasts available as well. So there's a lot of information out there, but how, in terms of the information that is out there, what do you think the scientists think about all of that coverage and whether they believe that the media is doing a good job? The next few slides are going to be from the Pew Center for People in the Press and a study that they did with the American Association for the Advancement of Science, where they surveyed 2,500 of their members as well as 2,000 general public. 18 to 45, I believe, was the age group for the public. So if you ask scientists how much does the public know about science, they would say that they know very little. 85% say it's a problem. And there have been plenty of studies to back that up. If you ask the general public some very basic science questions that we probably all should have known the answers to by the time I would say we were 10 or 12 years old, they will fail them. And in terms of which planet revolves around which planet, does the Earth revolve around the Sun or the Sun revolve around the Earth? You'd be surprised at how many people actually get that wrong. So their scientific literacy is pretty low in the United States. Scientists also believe that the media don't do a good job of distinguishing between those findings that are well-founded and those that aren't. And we're going to talk a little bit about the media's perspective on this as well. They're about split in terms of whether or not the news media oversimplify scientific findings, and they're about split in terms of whether or not they believe that the public expects solutions to problems quickly. Knowing that the majority of the public are getting their news online and through television, here scientists are rating whether or not they believe that the coverage on television or a newspaper, what the quality of that coverage is. And as you'll see, most of them believe that the media are doing a fair to poor job of communicating in both of these mediums. And part of that relates to the news hole. They don't have a lot of time. If you have a 90-second video piece, and that's pretty long on television, believe it or not, there's very little you can do in 90 seconds. So that's one of the challenges that television reporters certainly have. If you ask scientists what they're doing to be a part of the solution, you'll see that they rarely or never talk to reporters, that they don't write a science blog, they don't talk to non-scientists. So essentially, the media doesn't have a lot of interaction with a lot of scientists. There are a lot of scientists who may not believe it's worth their while. But one of the things that Alan Leshner also pointed to in the survey was the memorandum from the president around transparency as it relates to scientific study, particularly studies that are funded by the government, that there may be a push in the future for scientists to talk more openly about research that's covered by the government. So it's something to be thinking about. Again, if you asked the public, they're getting a lot of their content from television. Very few of them read science magazines. Very few of them visit science websites. So they're looking for these types of short programs, these short news holes to fill their curiosity, which may relate to the other issue that we spoke about before. If that's the only way in which you're learning, you're not likely to increase your level of literacy. So again, we know that of the 95 newspapers that were publishing special science sections, only 35 still do today. We all know about Science Times and the New York Times, which has done a really great job of covering science. They are still one of the few papers that has a science section. The Washington Post would be another. The Pew Center also does a lot of different types of studies with the media. They looked at the Pew Excellence in Journalism study, looked at editors, those who make the decisions at newspapers. They're the ones who determine how many reporters are going to be hired and what actually goes into the newspaper. And they asked them whether or not they thought that science was essential to be covered in their newspapers, and only 10% thought it was very essential. Which is disheartening, but they don't necessarily eliminate coverage. Again, instead they do things like this. They decide to consolidate it and cover it in shorter bites. They also use the services of other media. In the old days, because it's the only way I can think of it, when people used to send press releases, and in the old days when you watched television, there was a machine behind the anchor person, and it was generating what's called wire content from Associated Press, where you get photos, other types of things. So the media have become very accustomed to getting information that way. So if I'm working for the Philadelphia Inquirer and there's a big story today, yet I can't get to it, I may be more likely to pull that coverage from a wire, whether it's the Associated Press or Reuters, and see what they wrote. And if I like it, I may simply run it in my newspaper with their byline on it and not write anything. But I'm also much more likely to truncate that copy than to run it in its entirety as well. So the media, in addition to, this actually specifically relates to newspaper reporters, in addition to writing for the paper versions, they're also writing online, they're contributing to a blog, and 37% of them are tweeting. And tweeting, you can only use 140 characters, so it's a little challenging. Some of the best tweets that we've seen really draw people back, put links in and draw them back to actual websites to get more information. So I was wondering what people were tweeting about today. So I went on to Scientific American's tweet to see what they were tweeting about on Valentine's Day. And it's interesting to see how a scientific publication is trying to tie Valentine's Day to science. So a lot of their of the tweeting today relates to that particular issue: lust, love, attraction. So that's their way of trying to keep things relevant on Valentine's Day. Yeah. So essentially, we know that scientists and journalists have very different perspectives. Scientists expect questions and uncertainty. It's part of the scientific process. But journalists really are looking for answers. They're looking for a way to explain your research to the general public. So they're trying to find some way to make it relevant to them in their everyday life. Scientists like to tread carefully. I think journalists like a little controversy. Controversy makes a much more interesting story if you have opposing points of view. Oftentimes, even when there aren't opposing points of view, not in the true sense of the word, they will just find people who have different perspectives to make it appear as if there isn't some general agreement about the research. That works pretty effective. And of course, controversy sells. All you have to do is look at the proliferation of reality television to know that people will spend a lot of time watching anything that's controversial. The media also likes diverse voices. They want to hear, if Martha publishes a paper, they want to ask other scientists what they think about the research. It's their way of essentially trying to simulate a peer review process in a live situation, which isn't ideal, but it's certainly one of the techniques that they use. And they love writing about individual scientists, and particularly if they are studying something that's esoteric or something that can be particularly important, such as ways in which to rehabilitate people who no longer have the ability to speak, and using brain and human interfaces. They love that kind of research because it talks about solving a problem, and it's often, the scientists are often very dedicated to the work and very passionate about it, so it just makes really good copy. This is a PR News and a PR Newswire. PR Newswire is a major source of press releases, so typically there may even be millions at this point of press releases written every day. So a journalist would have to go through a lot of material on a daily basis. Most of the things that are put in press releases are relatively uninteresting, and the media know that. They're much more likely to look at those press releases if they're coming from a reputable journal or a reputable institution, because corporations put out tons of press releases because they have to. But if you looked at 2009, they did this survey, and if you were asking journalists what's the major purpose of your work, 5% said break news in 2009. A year later, that was up to 20%. So with all of this 24/7 news hole that they've got to fill, there's this quest to be the first to break a story and to be the first one to report it. And now with the internet, again, the process used to be much simpler because the wire reporter was guaranteed to write first. And now it's anyone's game. Anyone can write first. Whoever gets the information first wins. This is a cartoon that I took from the PhD Comics website. It's obviously it's overly dramatic for humor, but there's a lot of truth in this as well. And it starts off with you've got your research paper. Your university press office is putting out a press release. The press release goes out, and it's got all the caveats in it that it needs because you've worked very closely with your press office to put something out that you could be happy with. Then it goes through that process that we talked about. A Newswire is going to pick it up. They're going to write, they're going to post their story on the web. Somebody's going to see it on the internet. They're going to take that particular piece. So this is like a modern day telephone, right? As the story goes down the line, it starts to change. Based upon the headlines and based upon the amount of information that people choose to cover until it gets to your grandma. And I think that says, I'm wearing this hat to ward off A. So it started off that A and B had a potential relationship. By the time it gets to grandma, A actually causes something that's harmful, and grandma is trying to mitigate against the harmful effects of A. Again, it's not exactly the truth. This is what really happens. Newswires cover. They're the ones who are waiting to cover quickly. But now you've got web and television competing in the same time period. Daily print, because it's printed, it's still going to take that same process. It still takes, you had to lay out a newspaper, put it on a press, and you still have to print it. So they're not likely to break anything anymore unless it's an investigation. Radio, same thing. There's going to be a delay. And magazines are long leads anyway. These magazines are published weekly, so this magazine will get to a story faster than a monthly magazine, such as Scientific American, which only publishes once a month. When you look at how the media determines what's newsworthy, novelty is number one. If it's new research, new techniques, a new way of looking at something, everybody loves hearing about something new. They like conflict. So if it's new and it's not accepted, even better. That's an even better story. It's new and this guy is totally wrong. He doesn't know what he's talking about. That makes really good copy. The same for relevance. A lot of the stories that get covered, particularly as it relates to neuroscience, there's a lot of coverage of imaging studies right now. And it's not just because the pictures, they're pictures and they're pretty, it's because it's relevant. Everyone has a brain. Everyone wants to know why they do what they do. And these studies appear to be providing answers for why I do what I do. So I think that the relevance along with the novelty aspect is something that's very attractive to the media. The same with timeliness. The media has a tendency to cover things based upon whether or not they've gotten a communication about something, if they've gotten the latest issue of the New England Journal of Medicine. There are 5 articles in there that they say you should be interested in. I'm interested in one. I'm likely to spend my time on that. They're not oftentimes sitting around waiting for stories to happen. They're also looking for stories in whatever their geographic area is. Here in Philadelphia, the science reporter is going to be much more likely to cover science stories that are out of Penn than she is covering those that are out of NYU, for instance. Then there's prominence. The more prominent the institution, the more likely it will be covered. The same with spokespeople. The media are no different than anyone else. They want to have a spokesperson from the most prominent institution for the obvious reasons. Having a researcher from Stanford or Penn on your show is very different than having someone from someplace that's not. I didn't want to throw something out there because I just may throw something out there and someone may relate to it. But that's a huge factor in terms of who they're looking for. They want people with those kinds of research affiliations. And then proximity is really something for the local media. They're not likely to cover national news except in business sections. And if it's if it's world news, but mostly they spend their time covering local news. So they cover Penn, but they may not cover research around the world. The major source for neuroscience news are scientific meetings. The Society for Neuroscience, that happens typically every November, is a big source of news on an annual basis around neuroscience news. the organizers of the conference produce press kits, as well as they hold press briefings. They had 11 press briefings at the last meeting in November. And typically they have 3 to 4 researchers per press briefing. And the researcher gets up, so I'm the media, I get this press kit. It's got 11 press conferences, and if there are 4 abstracts presented per session, I have a booklet with 44 abstracts. So I have to leaf through and determine what I'm interested in covering and whether or not I'm going to be live and actually go to that session, hear that presentation, and question that person there, or whether or not I'm going to call them up and try and get an interview across the phone. With the shrinking of the newsrooms as well as the resources, fewer reporters are actually going to meetings anymore. So a lot of this is actually happening remotely. And again, they have this material ahead of time, even though they're not going to write about it until the day in which you present. So you get up, you do your presentation, you have a few minutes to give it to them, there's a Q&A, you answer questions, you sit down, and the next person goes on. So that's pretty much how they work. There's also the opportunity for them to just come upon you at a poster. Depending on the journalist, there are some journalists, some science journalists are very experienced, such as Malcolm Ritter from Associated Press. Malcolm has been with the Associated Press throughout my entire career. So he is one of the most trusted science reporters. He typically goes to all of these types of meetings. So he may come upon you at your poster, for instance, and just start a conversation with you. The good news is the media are always identified, so you always know who you're talking to, because the only way they can get into these meetings for free is if they have press credentials. So you will never be talking to a media person and not know it. It's always on their badge. There's always press there. The other major source are journal publications. Again, Nature, New England Journal, JAMA, most of the major journals send out press packets to the press on a regular basis so that they have all the information ahead of time. And the objective there, again, is they want to keep their publication top of mind as well. That's how they have gotten to have the status that they have, because publishing in one of those publications is something that every scientist aspires to. You know, you want to be the publication that's lowest on the list. You want those that have the greatest influence. So those publications have the same influence with the media. So they wait for those things. And when they get them, they peruse them and try and determine what it is they're actually going to cover. You can hold media briefings, and the New York Academy of Sciences is probably the one I'm most familiar with. They do this on a regular basis, on a monthly basis, various topics where they bring journalists in to hear from scientists. And journalists like those opportunities because it gives them time to understand a subject matter. So if they're in a situation where something is breaking and happening very quickly, they will have a lot more background knowledge to cover that story than if they hadn't participated in those kinds of events. So when you have areas that are not very well understood, or where there may be a lot of inaccuracy in reporting, oftentimes you can bring those people together and help them get a better foundation so that the coverage can improve over time. And then there are policy briefings, which I won't talk about a lot, but essentially policymakers are just another lay public, but they're very different than the media in that they're looking for very specific types of information. But when you communicate with policymakers, you're using the same types of skills as you would use in communicating with the public at large. So that's why I included them there. Whenever you have, all of you in your career at some point, if you haven't already, I would imagine, will be presenting information at a medical meeting, publishing papers. So you may be in a situation where some research that you participated in makes it out into that public domain, and everyone's interested in it and wants to know all about what you did and how it happened. Typically, universities have public affairs or press offices where all of that usually starts. That's usually where the writing of press releases begins, where you work with the communications folks to agree on the content of the release, and the university puts it out across the wire, and all the journalists are able to pick it up. The publications use the same kind of process, although they're using their own resources and essentially asking you to review what they put together. But hopefully they're working with your press office as well to make sure that information is correct. Then when you go to the scientific meetings, they have a press room there, a room that's specifically for the press, where all kinds of material can be made available to the press. Corporations typically provide media kits because when people have just a little time, they often need a lot of background that you can't give them otherwise. So they produce a lot of background materials and fact sheets so that people can actually get certain things right, particularly if it's something very technical and you want them to be able to use the terms correctly, so you define them for them, you give them a little background on the subject matter, all the things you would do if you had a lot of time to do it. When the media are going to write a story, the first place they go is to the internet. And the reason is because you can find a lot of information out there. So if there's a story coming out about poverty and the brain, before I write, I can go onto the internet and see what's out there already. I can see who's published on it, I can see who's written on it, I can see the types of stories that they've written. I could determine whether or not, based on this new research, I could write a different type of story, or whether I want to invest my resources that way. It's also a good way to find some material that's been simplified for the lay public. So if you're working on a particular topic, rather than just trying to wing it, you'd be surprised the kinds of resources that are already out there from scientific organizations and others to try and simplify some of the terms so that when you're talking to a layperson or to the media, you're already starting from a point where you've translated it at a level that they can understand. So essentially, I'm going to write a story, and as a reporter, I have the opportunity to organize all the material, I determine the focus, I write the story. That's my job. I really like this study about seeing in the brain whether or not you can tell whether or not two people were in love. I really, really like that story, particularly on Valentine's Day. So I'm going to write that story. Well, in order for that story to get written, I have to have agreement from my editor. My editor has to say that's a good story or it's not a good story. Let's say she says it's a good story. I want you to write that story. So I write that story. I give the story to her. She may change my story. She may change the tone of my story. She may tell me, you know, it's too sweet. I need a little edge. Didn't you pick up something edgy there? You know, wasn't there something? Didn't two people break up because of a brain scan? What can you tell me? So I have to go back. I go back, I give her the story. I'm done. She says, you're done. Someone else then writes a headline for my story. I don't even get to write my own headline. Someone else writes a headline, right? If you're not in love, who knows what the headline says, right? Take a brain scan, determine whether or not your husband loves you. It sounds silly, but you'd be surprised what actually makes it out there. But I don't have the opportunity, as the writer of this piece, I have no insight into that process, nor do I have any influence over that process. Once I write my story, it's done, it's gone. I'm done for the day. So that should help. Sometimes we hear from scientists, they don't understand why the headline is so sensational, and they often are, yet the content of the story could be perfectly balanced and perfectly okay. And that's the reason why, it's because different people are writing it. When newspaper stories are written, and magazines as well, they use what we call an inverted pyramid, where they do the opposite of what you do in science. In science, you're going to go through all of your methods, you're going to go through a long explanation before you get to, and here's what we found. Well, they're just the opposite. They want to tell you, here's what we found, and let me tell you how we got there. And that's essentially how these stories are constructed, and we call them the 5 W's, the who, what, when, where, and why. And they put them at the top of the story because they never know what's going to happen to a story in a day's time. I could work on this story all day. I'm ready to send it to my editor, and she says, you know what, you got to cut your story because something happened in Egypt today and we need this much room, so we're going to have to take some space away from you. So the reason they write this way is because it's much easier to cut a story when it comes to editing time based on this construction. And the next slide, I'm going to show you a little bit about that construction and how that works. So you can't see this very well, but essentially in those first 5 lines are the 5 W's. So they've answered all of those questions, and then there's a quote inserted from the researcher. After that, they give you more details about the study. This is a study that came out of the Society for Neuroscience that looked at smoking marijuana in teens. It's sort of a no-brainer, essentially, that the earlier you start smoking, the more it impacts your brain. So it sort of seems like a duh, right? But a lot of the media were attracted to it because of the relevance factor. You know, a lot of people have children. Marijuana is one of the most frequently used illegal drugs. So it kind of spoke to their readers. It's the kind of things that they would be interested in reading. That's another reason for you not to be smoking pot, because it didn't have enough of them already. So, but it got a lot of attention. And again, this is a relatively long story. 455 words would be a long story in the newspaper. And this is in the New York Times, but you'll notice this story actually started on the NewYorkTimes.com, because this person got the press kit, knew this press conference was happening on this day, so her story was ready to go online. Now that story also appeared the very next day in the print edition of the paper. But other things happened to this story. Other newspapers picked up this story written by this reporter, and truncated it, still giving Ronnie credit for the story, but shortened the story, took out the second part of the story beyond the quote. So the story lived on in various forms in other places, and that's a very typical thing that happens, which is why in our business we look to seek the media influencer first, is essentially what we do. You want to get to the person who's going to do the best job of telling the story, and those that the other media are going to emulate. And the New York Times is one of those publications. And here's how a segment makes it to television, a little like a newspaper, but different as well. Here the reporter produces a story idea, they perform the interview. However, assignment editors can play the same role in terms of producing story ideas. So on television, the reporter's not the only one producing story ideas. However, they are at the beginning of the chain, and as you go up the chain, the assignment editor and the producer are really determining what goes in that final package for that particular piece, and how long that piece is actually going to be. So they're going to look at all the footage that's been captured, and they're going to put it together and determine what that story is actually going to look like. Oftentimes the reporter can be there asking questions of the person that they're interviewing. Sometimes they're not. There are many ways in which you can interview a person for television. You can interview them via satellite, where they're not even in the same location. You've probably seen some of that when you see people in little boxes on television. They're being interviewed by satellite in a studio someplace else. There are lots of studios that are around the city where you can actually go and link up to a particular television station. So there are various ways in which you do that. When you look at the coverage of neuroscience, you'll see that there are a few areas that are getting a lot of coverage. Neuroenhancement's getting a lot of coverage because it has those elements that we talked about. It's something that's happening on college campuses. It's not something that started happening yesterday. It's been happening for a long time. There are many, I think what's happening is there are more drugs that are actually being used over time, and more drugs that actually have some research around them is probably what's happening. Anything on brain scanning, it doesn't even seem to matter what it is. It really doesn't. As long as there's a brain scan, and I think, again, it's because everyone has a brain, and the brain is like that final frontier of science where you really want to know why it works the way it works, and why we all talk about, I have 7 siblings, and it's so funny because our parents talk about the fact that we all taught you all the same thing, and look at how different you are. Well, clearly we all perceive things very, very differently, and we probably all came into the world a particular way. But it is kind of hard sometimes when you look at behavior to try and explain that. And a lot of these studies make it seem like you can actually explain why people act the way that they do. The brain in criminal behavior is big, simply because of the issue around serial killers and some of the research that's been done there. If serial killers have different brains than the rest of us, then surely they're not accountable for their actions, right? Of course not. So these are the kinds of things that are really getting a lot of debate right now, in particular because neuroenhancement is taking pharmaceutical products and giving them to healthy people, something that is very difficult as a concept for us, particularly because of some of the things that have happened in our society with prescription drugs, such as the OxyContin situation. And many of these drugs are classified similar to OxyContin, believe it or not. So Adderall and the stimulants are class 2 drugs, just as OxyContin is. And then there's neuromarketing, which I believe some scientists dubbed brain jacking, where essentially you can do these experiments now and watch people and how they perceive advertising. New Scientist actually did it with the cover. They were doing a redesign of their magazine, and they actually did their own experiment and chose the cover based upon that research, which is kind of interesting. So this is one of those brain
Finally,
scans.
tonight, putting love to the test. You can say you love someone with all your heart and believe it with all your soul, but could a brain scan tell the real story? Cynthia McFadden plumbs the mystery of love with the help of one brave and adventurous couple.
Is it possible to prove if you're really in love? According to anthropologist Dr. Helen Fisher, the answer is yes.
I decided that if I looked into the brain, I could perhaps find out what's going on when people are feeling that intense rush of romantic love.
Alana and Mike Clear felt euphorically in love at their 2008 wedding, but were alarmed to hear that 50% of marriages end in divorce. Would theirs be one of them?
I kind of wanted to find out at the beginning of our adventure together whether or not we were right for each other.
Mike proposed a radical idea. They would put their young love under an extreme test to see if it would survive.
Okay, we're gonna quit our jobs.
They set out on a motorcycle trip down the longest highway in the world, 8.5 months side by side. Dr. Fisher would test them both before and after the trip. Dr. Fisher says she has had people say they were in love only to have their brains say otherwise. Would Mike and Alana's brains betray them? Take a look at their brains before the trip. The illuminated area here in the Romantic Love Center is glowing like a Christmas tree. And after the trip, Alana's still is. But while Mike's scan shows a deep attachment to his wife, romantic love for her has virtually disappeared. Might all this science ruin the mystery of love?
Yeah, it's a bit like the Groucho Marx quote on comedy, that comedy is like a frog, if you dissect it, it dies.
Mike and Alana say they're still very much in love, test or no test, even if their brains disagree with their hearts, at least for now. Cynthia McFadden, ABC News, New York.
Oh, I believe they're going to make it. And you can see Mike and Alana's whole story and a whole lot more about who we love and why on a special edition of Nightline at 10 Eastern. And that is World News for this Thursday. I'm George Stephanopoulos for Diane.
So essentially, when you see that piece, it's actually a promo. This is actually a promo on the evening news, ABC Evening News, for a 4-part series on Secrets of the Mind. When I saw that original piece, I thought, oh my God, this is terrible. This is horrible. The other 3 pieces were exactly the opposite. The other one was on criminals in the brain. One was on rehabilitation. So they were very reasonable, and they were very interesting. So, but they led with this particular one as a teaser because it's funny, clearly, and again, people have this curiosity about whether or not you could tell certain things based upon looking at their brain. So, and I'm sure that you've all learned about the love center in the brain. The strong romantic attachment. I guess there'll be a new cottage industry now. You can get a brain scan before you get married, and you can tell whether or not your significant other actually loves you before you get married. Won't that be nice? So I brought a copy of my Time magazine because I read this every week. There are actually 3 news weeklies that are still out there in the market: Time Magazine, U.S. News and World Report, and Newsweek. Time Magazine, all of these magazines from time to time might actually have cover stories on neuroscience, although there are not a lot of them. They mostly cover it in small bits and pieces within the magazine. And again, everyone has a website. And that gives them the opportunity to go deeper into a story online that they may have only spent a small amount of time going into in the publication. Magazines, again, are having the same readership issues as newspapers. It turns out that the readers of these publications are similar to me. They are mostly baby boomers because, again, we're very familiar with these products. And as long as they're baby boomers, I guess magazines will survive. But as the population ages and as the population shifts, these publishers are trying to figure out ways they can stay viable because the model itself is a little outdated. Then there are these publications where the people reading these are people who are really science groupies. They like science more than the average person because these magazines focus on science and they go very deeply into it. So if you're reading these publications, you're probably more educated as well as from a higher socioeconomic strata. So every year, these magazines will report at the end of the year the top stories for the year. So I went through to look at what were the top stories that were neuroscience focused. So for Time magazine, it was really more of a medical story than a science story. It was about the blood tests for Alzheimer's disease, about biomarkers actually, which they're calling blood tests here. Science News actually had two studies. One looking at parasites, the other looking at neuron firing in rats during aha moments. So rats have aha moments. Then Nature and Scientific American had none. So neuroscience did not make the cut in those publications. But look at Discover magazine. So out of the top 100 science stories, 9 of them had some relation to neuroscience. A lot of them are scanning studies. People love those studies. We're going to talk a little bit about messaging as it relates to the media. We talked a little bit about that inverted pyramid that's used in talking in terms of putting stories together, but really talking about the way in which when you're communicating about your own research, a place you might actually want to start, as well as how to craft messages in a way that they are simple enough for the audience to relate to, and some tricks for doing that. And this quote has been attributed to Einstein, that you don't really understand something unless you can explain it to your grandmother, and if you remember from the cartoon, you might have to explain it to your grandma because she's at the end of that communication queue. So essentially, when you're communicating science, you have to figure out ways in which to make it relevant to the public. And it's not an easy task, for sure, because you want to be careful not to oversimplify things so that they lose meaning. But you have to remember that when you're communicating science to the public, you're communicating to the public, not to your peers. And I think that may be one of the barriers that stops people from really stepping back and thinking about it. There's this scene from the movie Philadelphia where Denzel Washington is an attorney and he asks the guy to explain it to him like he's a 4-year-old. It's the same concept here. Most newspapers write at an 8th grade level because they realize that that's the right level for the average consumer. Some of the publications like New Yorker as well as the science publications would write for a higher educational level. But basically you have to think about it. You're talking to someone who would understand at an 8th grade level. So you have to really think about the words that you're going to use. I'm not saying don't use complicated words. If you use something that's complicated, take the time to explain it so that someone can understand it. It's best if you can find a way. We're talking about, some people talk about neurons, some people talk about nerve cells. Nerve cells is much easier for the average person to understand than a neuron, and so making those choices when you're talking to lay people. So I pulled some actual quotes out of some media coverage because I thought they were particularly clever. Here, in the first one, the researcher uses an analogy. He's trying to use intelligence and explain it to try and have the journalists and the readers understand the work that he's doing around creativity and how you measure creativity. And he uses a highway as an analogy that, with intelligence, it's pretty much a very efficient But with creativity, it has all these side roads. So it's not perfect, but he's just trying to have them understand that some things are more straightforward, and creativity may have lots of pockets in the brain. Emotion, it's always good if you can find some emotion in what you're talking about. The next one is actually a quote from Martha, and she was able to make it relevant. This was talking about how being poor can affect the development of the brain. And here Martha talks about middle class versus lower class, and understanding how attention is focused based upon environment. And the last quote is actually one taken from a 60 Minutes piece on neuroenhancement, where Dr. Nora Volkow, who is the head of the National Institute for Drug Abuse, who is very concerned about the use of teens using prescription drugs, because prescription drugs have become the #1 problem for illicit use of drugs, as opposed to the ones that are truly illegal. And she's concerned about that. So when she was interviewed about the studies that had been published, her comment was, again, she took an absolute. She attacked, but she attacked in a very polite way, I would say. Those are the kinds of things that make it into print. And it's okay to have a point of view, but it's also, you have to be very careful not to insult your colleagues in the process. So I think she said what she had to say and kept it above the belt. Sometimes that doesn't happen. And here's a quote from Martha, actually, where she was able to take humor and popular culture and put it together. Where this was in the New Yorker wrote a 10,000-word piece called "The Brain Gain." Very, very dense article, and the journalist was reviewing this from various perspectives. And the journalists at the New Yorker go out and visit places, so they are describing a lot of what they're seeing in their story, which is why their writing is so rich. Essentially, she was. The funny part of her quote really relates to the fact that she thinks that we might be raising a generation of very focused accountants with with the use of these medications, but again, tying it to a generational issue in terms of how people work as well. And then there's the rhetorical question, where you essentially ask a question as a part of the interview. The media likes these kinds of questions, so they're likely to make it in. So I'm pulling these things out because these are the kinds of things that clearly got their attention because they actually made it. A lot of conversations never make it to print, never make it to television. A lot of people might be interviewed and never make it in because somehow either they didn't explain it simply, or they didn't use language that was understandable, or they didn't say anything that was particularly funny or clever. So the space goes to the clever. So essentially, when we talk about if you have an opportunity to stand in front of the media as well as to talk to them, that you need to prepare yourself for those interviews and think about the audience that you're dealing with. Think about who you're talking to. The media is a conduit to the masses, so you always have to think about, say you're talking to your next door neighbor who's not in grad school. Your next door neighbor might be in grad school, but let's say you have neighbors who aren't. If you were trying to explain your research to someone who wasn't a scientist, you would probably take more care in terms of how you would explain it to them and take some time to think about how you would describe it to them. So essentially, we prepare short messages before talking to the media, so that we can assure ourselves that the time we spend to them won't be wasted and we'll actually get in the coverage, but mostly so that you can control the interview so that the messages that are important to you, let's say it's your research, and there's some particular things in that research you want to be sure are understood, and you don't want the media to start asking you questions without having pursued that particular area. So you want to make sure you have your messages. Otherwise, this is what will happen. The media will call, they'll start asking questions, you'll start answering them. Now that probably feels very normal because that's what happens in a classroom every day. Someone lectures, you have a question, they answer it. And we become accustomed to that. But with the media, if you do that, then you're going to lose the opportunity to make sure that things that are important to you get in the story. So you want to start off by understanding what's important. And think about how others are going to look at your work, not just the work itself, but how might somebody, what might be confusing about it? What might be hard for them to understand, and be prepared for that. You also want to make sure that you craft some messages that are memorable, that paint a picture. Every journalist who's writing is trying very hard, and they're writing to paint a picture for the person who's reading it. And you want to help them as much as you can, if you can paint a picture. Obviously, if you're working in brain scanning, it's all done for you. All you have to do is give them a scan, tell them what happened. They can clearly make that leap for themselves. However, there may be things in there, things that you want to make sure that they communicate appropriately to the audience. Maybe you want to say, well, this research is really early and we don't really know if that's what's going on here. Maybe there are caveats you want to make sure that they give to their readers. I pulled this quote from Dr. Mehmet Oz. You guys probably all know Dr. Oz. He's a big television personality, one of Oprah's friends. And he, in talking about the study that was looking at exercise in the brain, this is a quote from him: "It's no surprise that exercise acts like Miracle-Gro for your mind, clearing the plaque that gunks up your brain's power lines." That's very consumer friendly. Now, I'm not judging these as to whether or not they're accurate. I'll let someone else judge them. But essentially, he's a recognized media authority who happens to be a physician. So anything that a physician who is in the media says is going to have greater credibility than a non-physician saying it. The public has a lot of respect for physicians, hence the reason that there are so many in the media now. And again, you just have to think about who you're talking to and what they're going to understand. And here he's clearly trying to do that. Most people know that you put Miracle-Gro on a plant and the plant grows. So he's trying to use some common language to explain that. And hopefully it's not far from what really happens. And again, another scientist used this analogy to describe working memory. That working memory was like a mental scratch pad. Use it to keep relevant data in your mind while you're completing a task. And he drew the picture of a cross-examination. When a lawyer is cross-examining someone, they ask a question, they've got to keep track of the answers so they can form other questions as a way to explain how that works. The media also loves it when you share personal experiences, things that might have happened in the laboratory. Here, Anjan Chatterjee talks about his patients in this very same New Yorker piece, which again was rife with a lot of different quotes from a lot of different people. And he coined the term worried well. You know these terms are working because remember I talked about how one journalist writes and then another journalist sees it. If they like it, they pick it up. The words that get picked up are clearly words that resonate with the media because they get passed on. So you see things like smart drugs, which actually started a long time ago when people were working on drugs for Alzheimer's disease. Now there's something else, you know. They've become something entirely different than that. They're just drugs to enhance your own cognition, even if you're not, you don't have a medical problem. But it's been around a long time. That book goes all the way back to the late 80s?
90s, early 90s.
Early 90s. So it's been around a long time. But he used that example, and what you see is in further coverage, they start using that term, the worried well. He also used the term cosmetic neurology. And the media just got it. They understood what that meant. So it starts pulling into other coverage. So when someone comes up with those catchy phrases, whoever captures them first, they get pulled along the way. There's only one problem with that. You have to really think about the phrases that you're using, because in the neuroenhancement space, you've got people saying academic doping, brain doping. So you've got those sound very different. Smart drugs versus brain doping, right? So when you think of brain doping, you really think of illicit drugs because doping is usually associated with street drugs. So you just have to really think about the words that you're using and what you want to convey. Maybe you want to convey that, and clearly someone did. One of the things we do when talking to the media as well is signaling main points that you have when you're talking to them so that they can understand, if there's a section you want to make clear, you want to point it out to them. In the old days when they were taking notes, they were trained that if they heard something more than once to go back and circle it. So they all still have that mentality. If I hear something more than once, that must mean it's important. If you signal something for me saying, I want you to remember this, it's important that your readers understand this, I'm also going to circle it because I'm not going to want to miss it because you just told me you don't want to miss that. And those are important things that you want to focus, and that works whether you're giving a presentation or whether you're talking to the media. You want to focus their attention. And here, these are just some ways to introduce it. The most critical aspect, people need to remember the key idea. The most exciting part, don't forget. And they do, they cue in. You really do, you can't help it. I don't want to forget that, all right. Good little tricks. And again, you always want to be excited about what you're presenting. There was there was a discussion about whether scientists were so accustomed to communicating in a passive voice, whether that was one of the issues, whether they could communicate in an active voice. So there was this discussion, and so somebody decided to do a study of research papers, right? You can go on Medline, you type in these phrases in your search engine in a particular way, it'll tell you how many times those phrases. And it turns out that they were mostly wrong. It's about 50-50, so, and that's in terms of whether or not they're speaking in an active voice. For the most part, when you're writing, if I remember in writing, you usually are having to write from a passive voice. It's not very common to use an active voice in science. It just isn't. But you need to use an active voice when you're talking to the public and not think about equivocating everything that you say. There are going to be some things that you really want to discuss in a particular way, but making sure that you speak in an active voice is really important. And those things that need to be in passive voice, that you're very clear about what they are. It's important when you look at your research that you try and put it in context. I mean, we all live, you need context to understand new information. How does it fit with what you already know? And I think sometimes when you see research, sometimes people think that the research kind of, it should be easy for people to understand how it fits. And it's not necessarily easy for the journalist who has no background in science to understand that. So just trying to have them, this is the first study to do this, and look at this in this particular way. This is pretty much replicating research that others have done. And at this point, we think this gives us a strong signal that. So again, you just want to put things in context for the reporter so that they don't have to make it up. And you also want to distinguish the impact on individuals versus society. Sometimes that gets really mixed up in some of the coverage. And maybe sometimes it's hard because oftentimes you're looking at a particular population under particular circumstances, and you really can't extrapolate beyond the study itself. But remember what we talked about in terms of how the media looks at the world. You look at the world. You have to find some way to help them understand what the impact of the research is. Why do you do it in the first place? And that comes up a lot. Why would you even go down this particular path? What problem are you going to solve with your research? And sometimes, a study gets done, you know that it's one step in a process. But remember, journalists don't look at it that way. I got this press package from the New England Journal of Medicine. They wanted me to pay attention to it. Clearly, they wanted me to do that for a reason. And they want you to help them with that as much as you can. And all of you are working with humans for the most part, correct? Oh, no. Okay.
For the most part, but definitely not everybody.
Not everyone? The human studies make it into the media more, so. You also have to recognize there is no single public. Each one of these publications has a different demographic. You're talking to an entirely different group of individuals by virtue of their age, their education, their socioeconomic status. There is no one size fits all. However, when you are crafting your messages, you have to think about the average consumer having, at an 8th grade level. And you also have to think about, when you're talking to the media, is the media knowing absolutely nothing about what you're doing. It's always a better place to start, because you also have that opportunity at the beginning of any interaction of understanding what that person knows, and before speaking with them, trying to give them more background before you have a conversation. And that's really important, because you don't want the person to be sitting there looking at you, not understanding some very basic things that they need to know before you can really talk about your research. So you do have those opportunities to have those conversations before you even sit down and talk to somebody about your research. And you always want to create messages. Again, it gives you greater control over the interaction, and make sure that the things that you want to communicate actually get communicated. When you're dealing with someone on the phone, you have the benefit of being able to have everything in front of you. If there's some statistics that you wanted to share, if there's a particular paper that you wanted them to take a look at, if there's something online that you thought was particularly useful for them to take a look at, you can have all of that in front of you and direct them to it. And that helps the journalist get a better story. Because again, when they're in a tight time period, they don't have a lot of time to go back and do the research that you may actually already have to help them. So you always want to have it at the ready to be able to help them. And you always want to be prepared. So I'm actually going to stop there, and we can go to some questions.